Yeah. All right, we are off. We are recording. Okay, oops. Get rid of that. Move this across a bit. I'll probably move it around anyway. Okay. So today I wanted to look at a bit more detail on SQL, some of the data types it offers, some of the expression types, and writing constraints, because that's an important part of writing SQL schemas. We've already seen a couple, primary key, that's a constraint, foreign key, that's a constraint, but there are more general constraints that you can come up with by writing an SQL expression. And the type of an attribute is also a type of constraint. Little pun there. All right. So what does Postgres, or what does the SQL standard give you? Gives you a bunch of numeric types, integers, which are 32-bit integers. Numeric allows you to specify an arbitrary size number. So you could say numeric 50 if you want to have numbers that have 50 digits in them. But apart from that, it behaves like a number and you can do arithmetic on it and so on. And real, I think I might have said float the other day. Wouldn't surprise me if float was an alias, but I think the official name for real numbers, for floating point numbers, is real. If you want to find out all the gory details, you go to the Postgres documentation, which I'm sure you've all looked at. And if not, you're probably about to when you start doing assignment work and so on. Okay, let me see. Where do I find info about data types? There's a header data type section. I might make the text a bit bigger. All right. So numeric types, integers, arbitrary precision, which is the numeric floating point. Oh, and serial. A serial type is an integer that has a value that is determined by the system when you add a tuple. You can get an automatically generated unique value assigned to an integer, and you do that by saying that attribute is serial type. Whose birthday is it? It's not my birthday. Money types, character types, things like varchar, char, text, binary data types. If you actually want to store binary objects like images or something in the database in an attribute, you can. Various flavors of date and time, Boolean, enumerated types, and so on. All right, so I've got more details. Oh, I stuffed up my formatting. All right, so strings, char-n is fixed length strings. And you don't say, if you say char5, it allows you to store strings of up to 5 characters. If your string is less than 5 characters, then it blank pads on the right. On the right, yeah. So ABC in a field of type char5 would be ABC space space. Varchar doesn't do space padding, but it does have a limit. I hate these guys on motorbikes in the back lane, very annoying. But it does have a limit on the total length of the string. No, it doesn't, because there are no null terminators in Postgres, or at least there are no null terminators in the strings that are stored in the database. So it knows how long they are. In fact, I think, if I remember correctly, it actually stores the length of the string at the start of the string. So, 2 different ways of dealing with variable length strings. put a terminator at the end like C does for the null, or somewhere store the length of the string and then have the string following of that length. And of course, you've got text, which is arbitrary size, doesn't do any blank padding, etc., etc. If you write a string and you put blanks at the end, they're still preserved. If you want to get rid of them, I think there's a trim function in Postgres. All right, various time types. Dates, as you'd expect. Time is time in time of day. So, 24 hours, 12, blah, 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 PM. Postgres has a very large number of ways of accepting date and time values, and timestamp for that matter can parse almost anything and turn it into a date or a time. So a timestamp is just date plus time on that date. And forget about that. I almost feel, in fact, I will. I'm going to fix it right now because it's annoying me. Let me see. No, it's not there. It must be. That's the bin. I don't want that. Oh, that's annoying. Did I close that window? Oh, no, donkey. Oh, no, that's the one. Right. Left out the ankle bracket. All right. So now go away. Oops, come back. Yeah, that's what it was supposed to look like. So a timestamp is date plus a time, and an interval is a length of time, a duration of time measured in day, or you can measure it in years, days, minutes, hours, etc. And you can have a combination of those: 5 years, 3 days, 2 hours in the future. I don't know what's going to happen, but maybe something will. All right, there's Boolean type, and because Postgres allows users to create their own types, it has a large number of data types that have been defined over time. So there's monetary type. So basically that means dollars and cents. So 2 digits after the decimal point. Geometric type, so you can talk about points on a plane. Enumerated types, and he'll show an example of them in a minute. They're actually user-defined types. And there's also a big range of types, including JSON and XML and other data types like that. So they can be native in your Postgres database. Or if the built-in types aren't enough, you can make your own. So you can make, so there's a SQL command create domain, which allows you to define a new type. It's not really a new type, but you can give a name to a type. And in fact, you don't even need to put a constraint. So if I decided that I wanted to call the integer type number, then I could say create domain number as integer. And then throughout the rest of my schema, I could use the word number in place of integer. I'll show you some examples of that in a moment. You can also create enumerated types, as I mentioned up there. So you basically give a name to the type, and then you give it a sequence of values. The values are strings. Basically, Postgres uses strings, single quoted strings, for anything that's not an obviously parsable type like integer, numeric, real, Boolean. Date and time done as strings. So you have to say single quote 2021 09 23 for today's date, for example, but it has to be enclosed in quotes. And yeah, any funny type. I think monetary types don't need quotes. Booleans don't. geometric types do enumerated types. Yes, all the individual values for the enumerated types are strings. All right, so I think let's take a look at some examples. All right, so if I move this away and go over here, if it's not going to work, I need to move it much further away. Oops, I moved it too much further away. Come back, come back. Lost control of the screen. All right, there. Now it's gone totally the other direction. Great. Point on a plane, yeah. All right, so yeah, it has a syntax. I don't want to change the size. I just want to move it. Haha. All right, so let me see. So types. Oops. So a domain isn't really a new type. It's just putting a constraint on an existing type, whereas an enum is quite a different thing. All right, so let's take a look first at oops, great. Colors, I will use the English spelling as enum. So if you only want to deal with 3 colors, you could do something like that. If you wanted to represent mood, so that creates a data type called mood, and you could define an attribute. Not sure about 3D. The way you find out is you go and look at the Postgres manual. You can define an attribute of type mood, and then you can insert a tuple. Oh yeah, maybe I should do that. So I'd use it like any other data type. And if I wanted to add a person into this table, I could then say insert into people. So the reason it says values there is you're actually allowed to have multiple tuples following this, but I'm just going to insert a single tuple. So that would be inserted into the database, and there would be a text name, John, and a mood type value, happy. One thing that enums do is they actually define an ordering on these things. So if I wanted to compare moods, sad is actually less than happy. And similarly for colors, red is less than green, is less than blue. Yeah. All right. So that's a quick example of enumerated types. What I'm talking about here is I want to actually define domains. So they're not quite as create domain positive integers. Oh yeah, I think as is optional. So clearly they're integers, but we want to restrict the values to something greater than 0. So you write check, and an expression that gets evaluated when you try to insert something into the database checks that the value that you're inserting is greater than 0. So that would define a data type posint. And once again, let's do a quick example of how we might use it. Here's a cheeky way of defining points. So you don't need to actually use the points data type. You could define a sequence of tuples. And here we're talking about points that are in the upper right quadrant of the domain of possible points. Oh, I'm surprised someone didn't pick me up on that. There's an extraneous comma there that Postgres wouldn't like. You know, I normally use an uppercase letter at the start of both type name and table. But remember I said yesterday that in Postgres, all of these things are mapped to all lowercase internally. So posint would be, you know, I could even write something like this, and that would work fine. And that first insert would work fine. This one wouldn't, because the value of this first attribute would fail this check. It's not greater than 0. Yeah, you can. Yes, you're quite free to mix lowercase and uppercase as much as you like and make words look extremely silly. What about 3 null? That would actually work, because when I define attributes like this, that allows them to be null. So yeah, if you want to kind of does make sense, but if I wanted to enforce that they weren't null, then the way to do that in Postgres is to say not null here. Actually, that's an interesting question. What happens if you put what in a mood angry or something? Would it just become null? No, it wouldn't. It would fail because it's not a valid value of the type. The only valid values of type mood are sad and happy. Yes. So it would fail. So if you want an example, why do I write that so big? When students plagiarized, that would not be okay. However, I could write insert into people values Andrew null, and that would be fine. And similarly, I could even put a null name. So if it doesn't make sense for an attribute to be null, then you would put something like that. So certainly you don't want the person's name to be null, because you don't know who you're talking about. Yeah, all right. Someone just asked about default values. thinking. I've lost my track. Not well, yeah, all right. But it's kind of all right if you don't know someone's mood. That makes sense. Would also be okay. All right. Yeah, a question mark about a question about default values. Yes, you can have default values. And you could write something like that. That kind of doesn't actually make sense, because if it's not null, you're never going to use the default value. So you could do something like that. And the way that you'd insert a tuple like that, I think there's two ways. I should have checked this before I started the lecture, but one I certainly know would work. When you're inserting tuples, you're allowed to specify just some values. And I say I'm just going to give a value for y. Let's say 5. And so since I haven't given a value for x, it'll use the default. In theory, you don't need to specify a primary key in SQL. That's another way that it's different to the relational model. The relational model has all relations have a primary key. So that would insert 0, 5. I have a feeling that you can also do this. And you could go and check that yourself if you wanted to make sure that I was telling the truth. All right, so where are we? Primary key isn't required to be specified, no. Mood angry, can't you not null them in the table def? Yes, that's what I did. Domain is useful when you want to reuse a constraint multiple times, definitely. So it's, it's the kind of thing you have when you do a type def in C. Presumably you want to use that type in multiple places, but 0 isn't strictly greater than 0, thank you. All right, so it wouldn't make sense to do that. Interesting, I wonder if you tried to do that, whether it would. Bit of a strange default value, but there you go. The table direct, yeah. Interesting question. I guess it would. I haven't actually tried that, putting in a value that as a default that violates the domain constraint. Interesting. Try it. Should I try it? Maybe I should. All right, let's just test that out. All right. Oh, damn. Have I got a Postgres server running here? No, I don't. Oh, what have I called it? Yeah, I call it. All right, I call the ALS PG one here, just to be confusing. Let's see. Yes. Oh, and if you wanted, you'd see thousands of databases. All right, so I do have, I think there's a database called JAS. try and, so that worked because, yes, footy, movies, beers. And if beer wasn't enough, that's right. Well, one's a very simple beer database that I'll use for demonstrating SQL, and the other one is a more serious one of the type that we'll be using in assignment 1. Okay, so that x.sql actually had, that was valid, all right? Let's put an invalid value there. Interesting. Well, there you go. It doesn't check the default values as being okay for the domain. Is that right? Is that what I put? And I wrote it out. Yeah. All right, that's interesting. What was this called? Points. So let's see if this will fail. Yay. All right, so that's quite interesting. Yeah. Bit sloppy Postgres. I'm surprised it didn't make it check here that that was a valid value and complain at the time you built the database. All right. Learn something new every day. Okay, positive integers, marks. All right. Once again, this is kind of create domain marks as, once again, we could say integer, and this time we can use, yes, check that the value is between so Postgres has some pretty old throwbacks to the days when they thought managers could actually write SQL. I'll just make sure that, yeah, is between inclusive. Yes, it is. Yeah, right. So that'd be a way of defining marks. And once again, if you're outside the range, blah, 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 any insertion will fail. Now you could say, hey, wait a minute, marks are real numbers, they're not integers. Or are they? In fact, I think in my UNSW, it stores all marks as integer values. I don't think you can use between on real numbers. So we won't try to do that. All right, UNSW course codes. So once again, we can just create a domain. Well, you could have an enumerated type and have an extremely long list of course codes, but I'll just call them C codes. All right, what here? Well, one thing, they're always going to be eight characters long. So we could define them as char 8. But that would allow things to, yes, quite right. So you wouldn't use an enumerated type. One thing it could do, you could have a table of course codes and then relate the actual value to, ooh, or can you? What I was going to suggest was something like this. So if you did have a table of course codes, you could check what we, well, this is again a bit long and obscure. So I could look up the course code, that's the value, check how many times it appeared, and hopefully it would appear once. So count the number of entries, number of tuples in the course codes table that satisfy the property that they have the value that you're checking. And if there's only one such thing, then that's fine. Maybe you would want to do that, but that seems unlikely. In any case, I doubt that that'll work. So we need some way of checking the value. And basically what we're interested in is a string, an 8-character string, where the first 4 characters are uppercase alphas and the second 4 characters are digits. And one way of doing that, which would probably be the most common way, is to use regular expressions. Now, one of the tutors pointed out, oh, you haven't done regular expressions. Yeah, that's right. So I will give a quick intro to regular expressions. The first thing, Postgres uses the tilde, and basically what we're saying, yeah, if you like, the value matches this pattern that I'm defining here. That part of the pattern matches 4 uppercase letters. Okay, so this part says any uppercase letter, and this says repetition of 4. Yeah, I know most of you haven't done 2041, but I'm very surprised that we don't cover regular expressions elsewhere in part of the core. And if you want to check that the second 4 digits, the second 4 characters are digits, you can look for the character, any of the characters 0 to 9. That'll match a single digit character, and you want to repeat that 4 times. So that would be a check for UNSW course codes. There you go, lovely. Are there any, what do you mean, are there any other examples? Yeah, there's plenty of examples. If you go and look in prac exercise 3, there's an example which involves digits and hyphens and things. I think it was a bank account number or something like that. Are there any ways besides regex not to check this? If you had a simpler type structure, so Postgres has 2 pattern matching mechanisms. It's got tilde, and there's also a not tilde, which is exclamation mark tilde, which means does not match. But there's a second, yeah, that's probably true. But the second way is the old syntax, the standard syntax. So regular expressions are not standard. So this is a Postgres special, but The old syntax is really, well, you can't even do it for this example here using like. So if I had a table of people and I wanted to find people who were called John, then I could do it like this from so like allows a limited range of patterns. Percent matches any number of any characters, so any arbitrary string, as long as the thing starts with John, then that will match that pattern. So if you want to, you could equally well do that in, in regular expressions, but you need to be a little bit more careful. You want the thing to start with John, so that specifies start of string, and that would probably be enough. So as long as the name starts with the 4 letters J-O-H-N, you're laughing. Yeah, that's fine. It allows weird strings like that. There's a one in the chat. Yeah, bad luck for John. Ah, all right. Let's see. Can I remember how to do? You can have optional. I think if I put that, that would mean that you didn't have to have an H. So it would match J-O-H-N or J-O-N. I think. I haven't played with regular expressions for a while, but all these ones are pretty kind of standard. So caret matches the start of the string and dollar matches the end of the string. So if I put this would match a string that consisted only of J-O-N or J-O-H-N. Oops, better get out of the way there. So that pattern would match those two possible strings, J-O-N, J-O-H-N. If I took the dollar away, then sure, it'll match J-O-N at the start of the string plus anything following that. If I wanted to be explicit about anything following that, I can write dot star, because dot matches any character, star means any number of repetitions. So in fact, dot star is pretty much what percent matches. If I took away that, let's take away that as well, it's just confusing. If I tried to match that, that would match strings that had the characters J-O-H-N, capital J, anywhere in the string. So, you know, Fred Johnston would match that kind of thing. Yeah, and if you want to be casing sensitive, then I think you can do that. And then I could do that. And so it would match those 4 characters anywhere in the string. Like also has a case insensitive variant called I like. So you could do that too. And notice that it hasn't made, it has a syntax highlighted I like. That's a bit of a surefire giveaway that this is not SQL standard syntax. I'm surprised that it hasn't highlighted domain, because that is SQL standard. Interesting. All right, so UNSW course codes. Oh, and we've been looking at names. All right, so the description of what's a valid name here says alphas. Sorry, because it's in, oh, I like, yeah, case insensitive. Thank you. Right, so a person's name, well, it's pretty damn difficult to come up with a valid description of a valid name. Let's assume that we're dealing with just all Roman characters in the regular alphabet that we use. So you're allowed to have alphabetics, you're allowed to have spaces, you're allowed to have minuses, you're allowed to have quotes, so you can deal with things like O'Brien and hyphens for Barrington hyphen Johnson or something like that, those long English names. All right, so coming up with a regular expression for names is pretty much impossible. You may as well give up, but if you really want to try, clearly we're not going to limit the length of names. So if we wanted to, we could try and think of what's the longest name in the world, and we tried that yesterday, and you can probably get up to a couple of 100 characters, but forget it. Well, Andrew Taylor asked us to do this impossible job in 2041, and did you succeed? I don't remember. All right, let's have a go. So clearly, like type patterns aren't going to work. Oh, and by the way, I forgot to mention, so like has percent as a pattern element, and it also has underscore, which matches any single character. So percent matches any number of characters, underscore matches any single character. So I'm not sure what would be the point of that. It would match JOHN, it would match JEHN, whatever. So not really that useful in that context. Yeah, exactly. Is that a name? JEHN? All right, let's have a go. One thing you could say that names generally start with an alpha. So we could say that, and an uppercase alpha for that matter. So we could say a person's name starts with an uppercase letter, followed by any kind of combination of, this is where it gets really difficult. So yes, any combination of A to Z or A to Z, so that'll match any alpha character. And if we want to allow spaces, we can put a space in there. And if we want to allow single quotes, we could do that. And then we got, oh, beautiful. Ooh, that's interesting. I wonder if that's going to work. I have to try that. Followed by star, having that, I remember, silly me, of course. All right, if you want to escape a single quote inside a single quoted string, then you got to double it up. Yeah, no rights for people who have number names, no rights for people like Prince who have a symbol as their name. All right, so let's see. See, this will allow silly things. It'll have to start with an uppercase letter, that's fine, but then any random combination. Oh, I forgot hyphen as well. Hyphen. No, notice hyphen has to be the last character because it also has a special meaning in here. So that's the range of characters from A to Z, and the range of characters from lowercase a to lowercase z. The x88 to 12 would be ignored by normal name checks. Yeah, probably. No, and if you want to support Unicode, yeah, quite right. So I agree with Jimmy. It's probably not worth trying to do this anyway. Doesn't this mean that A? Yes, it does mean that. What does star mean? Right, arbitrary number of repetitions. So this will match any single character, lowercase, yep, that's true. Well, I'll just do this. This will match any single character in this range of characters, and star means 0 or more occurrences of that. If you want to insist that there is at least one occurrence, then you change the star to a plus. What does it say that for? Is there, oh, dots. Oh, yeah, dots. I forgot about dots. You could have them. That's true. And if we want to make sure that's all that we've got in the string, we could put $1 at the end. Do they have commas as well? Really? Are there commas in names? Maybe. Right, I'll allow that. So we'd be allowed to have dots, fair enough. J.A.Shepherd, for example, might be a valid name. Comma, don't know about comma. But this will allow rubbish, as people have pointed out, that will allow A-12. As, oh, no, it won't, because it won't allow digits. So we're not allowing digits, but it would allow A-B. Yeah, sure. So regexes for complicated things like this basically don't work. So you may as well just define it as text. Person name is a text string. And if you really wanted to, you could create a domain person name, and everywhere in your schema where you wanted to have an attribute that was a person name, you could use person name rather than using text. So, it gives you a little bit more descriptive power, if you like. Similarly, when you've got integer values, if they represent things like units of temperature, so you could create domain degrees as integer. Things like that, and then you can have ABC is of type degree. Plus stops you from doing a one-letter name. Yes, sure. Do you know anyone with a one-letter name? I'm sure you'll come up with one. Dot is, yeah, sure, things like that. Max, this check would actually allow 2 or even more capital letters at the start. It would. But you can't, if you want to try and do this, you couldn't do that, because then you wouldn't be allowed to have any capital letters in the name. Yeah, enough on regex. All right, so go and have a look at regex101.com. Sounds like a good idea if you're interested in that. Right, so I wanted to actually part of this thing was to take a look at converting this into an SQL schema. It has, and I think we'd started on it yesterday. All right, so that'll just be a whole lot of junk in there. I'll get rid of x.sql. So once again, these files will end up in the linked to the web page. So remember that to implement weak entities and their relationship to strong entities, we had a table for the weak entity. So that's their name, obviously. Type of relationship to the employee, the phone number, so you can contact them when the employee gets hit by a forklift. The employee itself, so we need to know which employee this person is related to. And this is obviously a foreign key referencing the employee table. They're only related to one employee. In fact, we could have them related to multiple employees. But in any case, each entry here will have them associated to one employee. Foreign key referencing the social security number of the employee. And remember that I said the primary key anywhere. No reason. In fact, ideally what we do, I'm not. And then we could define it however we liked. So you could create a domain for it. And everywhere you needed to use phone numbers in the database, you could use that. And, potentially that could be a regular expression. If only there was, yes, exactly, for phone numbers. Hey, if you really want to. But that's almost as difficult as people's names. Anyway, the important thing was that these weak entities don't have their own primary key. You can only form a primary key in conjunction with the key for the corresponding strong entity. So the combination of those two things gives a primary key for this table. All right, let's take a look at some other parts of the diagram, which I can gradually bring into view. All right, department has a name, which is a primary key. In general, it's not a good idea to use strings as primary keys. I would normally stick in an ID field, so an integer, internal integer ID. Departments. All right, so name is text. Look, it didn't fit. Probably text. All right, we don't need to explicitly say not null. Oh, there you go. So a department's got a phone number. You beauty. It goes till 11, so I'm going to finish soon. So how convenient we have a way of describing phone numbers in multiple places. And the other thing here, primary key name. So you can't have a department with no name, but the way I've written this, you could have a department with no location. So you might want to add, and this all depends on the semantics of the domain. All right, so this we can look at a couple of examples of, well, gee, well, you saw the request from people. All right. I guess the people who turned up are the ones who want it at 9. Maybe I'll think about it, and maybe I'll start earlier next week. All right. Might be better for you. I don't know if it's better for me. Okay, what do we got? Employee works in a department Well, all right. So works in is, since it's a 1-to-n relationship, we put the relationship as a foreign key in, oh, no, it's a text. Oh, works in a department. And I remember I was going to do, actually I won't, I'll use the shorthand for foreign keys, references, department name. All right. Of course, that's not going to work because at this stage, so Postgres reading in a .sql file like this does it top to bottom, doesn't do multiple passes. And when it gets to this point, it's going to say, wait a minute, what's this department's thing? Oops. So there's a couple of ways you can handle that. I think we probably are, all right. In fact, since we cannot have an employee who doesn't have a department, we can say that, and we'd really have to define departments first. And if you've done prac exercise 3, you'll see examples of ordering. All right, a manager. Every department has a manager, and a manager is an employee. Oh dear. And it has to be not null because you can see there's a total participation constraint here. So every department has to have a manager, but not every employee is a manager. All right. So we can indicate that by not null and references. Now we have a problem. We have circularity in our referencing. We can't define departments because we need to have employees, and we can't define employees because we need to have departments. What to do? This one is potentially a little bit tricky. One thing we could do is the following. We could initially define departments without managers, and we could alter the table afterwards to add the manager field. Or similarly, we could do employees. We could not include a works in field. We could add that field later using an alter table. Can you make managers? No, because that would allow people to manage multiple departments. And we know that it's a 1-to-1 relationship. And yes, also it would be a problem to work out whether all departments actually appeared in the managers table. So no, you shouldn't make managers a separate relationship. All right, let me see, I'll finish quickly. All right, so what to do? Let's do this. So department starts out initially, and we don't have managers because we can't. But what we can do is add them in later. I'll do table departments. Oh, now I've forgotten. I'll have to go and have a look at the manual. Where is it? Postgres documentation. Learn to work your way around this thing because it will be very useful when you're writing queries. All right, SQL commands, alter table, change the definition of a table, alter table, blah, blah, blah. Action, and the action is add a column, column name, data type. All right, so alter departments. It's pretty. Add a column manager. I'm going to have a guess here. I have been extremely annoyed with that copy and paste that's been going on. That actually worked. Good. All right. So I could do something like that. So by the time I reach this alter table statement, the employees table actually exists, which is good. All right, that'll do, I think. There's nothing particularly special about this. All right, employee works on a project. This is an end-to-end relationship, so we would create a separate works on table to link employees and projects. Because we have a separate table, we don't have a guarantee that every project is going to appear in this table. So the SQL doesn't actually implement that. One employee one. Yes, it does. But we don't, all right, to implement one-to-one relationships, we simply need a foreign key in one of the tables. And the rule of thumb is that we put the foreign key in the table which has total participation, if one does. I mean, in theory, you know, we could still work out a manager by sticking employee managers, and only some employees would manage departments. That's fine. We'd still have that relationship captured. But you only need it in one or other of the tables. So having the department reference who's the manager works. Having an employee reference which department they manage, even if they don't manage a department, would also work, but would be less efficient because you'd have this field managers in the employee table, which would largely be null. If we have a small number of departments and a large number of employees, we're not going to have many managers. So it's better to put managers in, or the manager link there. All right, I think I'll type up the rest into this file and I'll put that on the website so you can have a look at it. All right, I think that will do for today. All right, so next week we'll continue on. We'll say a little bit more about mapping ER to relational. We haven't talked about subclasses, superclasses. That's a whole thing in itself. So we'll do that, and then we'll get on to SQL, the query language SQL. All right, will a tutorial be recorded? I can't force the tutors to do it. Ask your tutor to record it. And by the way, I should have had this up already. Where's MS3? Oh, where are you? Yeah, there. All right, tutorial links. If you have a look here, whatever tutorial you're in, it will tell you how to get into it. Hopefully, some of these meeting links have been a bit flaky, and there's a link to any recordings that the tutor makes. So that's it for today. I will stop recording.